Hello, welcome back to Entity Framework Core Fundamentals. I'm Julie Lerman. This module will introduce you to a wider variety of the mappings you can achieve in order to persist your very nicely designed classes that might not align so well with the shape of your database. But rather than being forced to change the design of your classes in order to make them easier to persist, and that's something I will guide you to avoid, there is so much you can do in the DB context configurations to bridge the gaps. As part of your fundamentals education, you should have an awareness of other possibilities with EF Core that are important to even the most basic work you might be doing. So in these last modules of the course, I'll be covering those types of topics at a high level, just to make you aware so that you know what can be achieved and to give you a quick look at some of these features. We'll begin by ensuring that you know what to expect from strings in your classes with respect to .NET's project nullability and how EF Core convention responds. Then I'll go over a list of mappings and conventions to be aware of that we haven't touched on yet. In this course, I've focused solely on Fluent API configurations, so I do want to give you a quick look at data annotations, the other way to configure mappings, and make sure that you understand why I mostly ignore them. Then I'll be sure you're familiar with a few specific scenarios that you might commonly need to address in your software, such as EF Core support for persisting some data as JSON strings, the ability to persist properties whose types don't have a direct correlation to database types for EF Core, how to apply configurations in bulk, in other words, configuring a type that might be used by properties across a number of your entities rather than just configuring one property at a time. And we'll also take a quick look at mapping complex types and value objects. Because this module is providing a high-level overview of these features, there isn't a before solution available in the downloads, but there is a solution where you can see all the code that I'm showing you in this module. We've been ignoring Visual Studio's warnings about possible null properties for the entire course because I didn't want that to get in the way of the important lessons. But now it's time to get a better understanding about this and how it affects EF Core. Reference types by default are nullable, and the most common reference type that you use is a string. Because it's nullable, that means it can exist without being initialized, compared to an integer, which by default initializes itself to 0. However, having a null string can lead to the possibility of attempting to perform operations on strings that will result in a null reference exception if the object is null. Thanks to a project setting called Nullable, which is enabled on all new projects by default, the compiler will try to alert you to places where this might happen by providing warnings in your code. How it does that, however, does depend on the code. If you've created a new project and a new class with strings, you'll see the effect right away. The string properties will have warnings suggesting that you make them non-nullable. If you access methods or properties of the string that will cause those exceptions if the property is null, the compiler won't point those out because it's pointed out the properties already. But this line of code will throw an exception at runtime. And there's the possibility of explicitly making those strings nullable in the code. Alternatively, you could disable the nullable setting in the project. But with both of those paths, now you're on your own to make sure that your code is protected from the null exceptions. But why am I talking about this in an EF Core course? It's a lesson for C#, but of course I have a reason. EF Core will map these strings based on the nullable setting of the project. Normally, you would expect a string to be nullable, and therefore the char or nvarchar column it maps to would also be nullable by default. And this is how EF Core will interpret it when nullable is disabled. You can always force the map database column to be required with an isRequired configuration. But keep in mind that the database is the only place that constraint will be enforced. EF Core won't do that. You'll need to ensure your business logic protects that requirement. But if you have nullable reference types enabled and you haven't explicitly made the strings nullable, then EF Core's convention will be to map that to a non-nullable column. And while this doesn't affect the database mappings, The compiler will also warn you about other properties that haven't been instantiated, ones that could be problematic if null. For example, if I remove the new instantiation on the books property, that too would get the warning squiggly line. And with NRT enabled, if you do have a string that explicitly needs to be nullable, you can always just specify it as a nullable type, as I'm doing in this example, using the question mark shortcut to define first name and last name as nullable strings. And that will also infer the database columns to be nullable as well. There are many ways to take control over how .NET and how EF Core respond to nullability in your classes. But now you can also see the default behavior, which is the path that I took throughout the whole course. In the EF Core 6 Best Practices course by Michael Perry, he has a whole module on nullability in EF Core that will provide you with a deeper understanding and some excellent advice around nullability in EF Core. Now I'm going to go through a slew of conventions and mappings that I just want you to be aware of, but I won't be demoing them all. Do look for a course on mappings in the EF Core path. Here's some that you may have noticed as we went through the course. By convention, EF Core assumes that column names will match the property names of your classes, and you can use the has column name mapping on a property if you need to change that. Column types are determined by the database provider. For example, the SQL Server provider we've been using will default to nvarchar max for any string that you're mapping. The hasColumnType method for properties in the model builder lets you specify the type you want to map to. But you can't go off the rails here. EF Core still has to be able to do the conversion. But you can easily do things like change the length of a char or make it be a char and not an nvarchar. But if you only want to change the length, there's also a mapping for that. Has max length. Here's one that you saw anytime we ran migrations. Has precision. The SQL Server provider's default scale and precision applied to decimals is 18 and 2. And migrations kept warning us that since we didn't specify it, this is what it was using. Now, it doesn't warn us about all the other defaults, but if decimals aren't what you want them to be, it could really mess up your persistence. So that's a warning that the EF Core team decided needs to be surfaced. The required or optional setting of a property is by default driven by the nullability of that property's type. You just saw that with the strings when we reviewed nullability. But we also saw how an int, which is non-nullable by default, when it's used for a foreign key, force that entity to always have its parent defined. You can change properties to be nullable or use the isRequired mapping in configurations to affect this default behavior. We didn't talk about database indexes, but I do want you to be aware that by convention, EF Core will infer an index for any foreign key that you define. And you can configure indexes as well, adding and removing them, naming them, applying filters for databases that support filtered indexes, and even specifying multiple columns for databases that support that kind of configuration. Throughout this course, we let EF Core follow its default of mapping every property in every class. But it's possible you might have properties that you don't want to store in the database. For example, a property that you calculate on the fly. You can configure an entity to ignore properties with the entity ignore method in your mappings. Here, for example, in onModelCreating, I'm drilling into the book entity, then calling ignore, passing in a lambda expression for that base price property that I barely touched in any of my demos. Checking the data model with the EF Core Power Tools diagram, there's the book class, but the base price property isn't there anymore. What's more interesting is that anytime I query or update the book, EF Core will ignore that base price property. Queries will have all the columns except for base price, and insert or update commands won't involve the base price either. Even if the base price value has been populated in the object, save changes will just ignore it. Another common convention is that by default, all reachable entities will be included in the data model. For example, if I have a DB set for author, but I don't have a DB set for book, the book class is reachable from the author class because we have that navigation property. So the context will find books and include it in the data model. And if I didn't have the books DB set and there was no books property in author, because I've now made some reference to that book class in on-model building, the DB context will pull it in anyway. It just won't have that default relationship with author anymore. But there are times where you won't want a class to be part of the data model. And in those cases, you can use the model builder ignore method to exclude it. At the very start of this course, when we looked at the book class, I pointed out that we can finally use .NET's date-only type in our classes, and EF Core will map them to the simpler date data type in SQL Server. And we can also use the time-only type when needed. This is a very important change to EF Core, thanks to a contribution from Eric E.J., the same MVP behind the EF Core Power Tools. Date-only has been in .NET for quite a while, and SQL Server has had that simple date type for a number of years as well. But until EF Core 8, we were still forced to use date time in our class and our database if we wanted EF Core to map it by default. And this was a real pain because it's much more common to only need a date or a time and not the full date time type. And there can be side effects of having to manage an extra part in date time when you don't even care about it. The published date property in book is a great example. It's a book. It's not a blog post or something where the detail of that is more critical. We truly only need the date. So if you're building new apps, definitely take advantage of this. Refactoring existing ones might take some extra care and testing. Here's a mapping that came to us in EF Core 6. It's called Auto Include, and it's perfect for entities where you know you always want to include a relationship anytime you are querying it. So you can build that rule into the data model and not have to worry about including the property every time you code up a query for that entity. For example, if we had decided that any time we query for an author, no matter what, we want the books to be pulled back as well. And we can configure that in the pub context with the auto include mapping. I've got one last slide here, but I'm not going to explain these features, but they're features that people do ask about. So I simply want you to be aware of the fact that EF Core does indeed support inheritance, backing fields, concurrency tokens such as row version, composite keys, database value generation, not just for primary keys, and the ability to split the properties of an entity across multiple tables if needed. So in case you've been wondering about these features, now you know that they do exist, and you can always learn more about each of them in the official EF Core documentation. There's also conventional and configurable support for enums as well.